since we always forget.
All right.
Yeah, we're good now. All right. Well, how are you doing?
Not too bad.
Good. Yeah, it was nice to not have to worry about new content this week.
Yeah.
Although preparing for the test still won't be a cakewalk, unfortunately.
Yeah.
Yeah, I'll have to see how much of this stuff I can remember. I'm not quite sure. All right, are you ready to get going, or?
Yeah, I'm just getting things set up right now.
Okay. Okay. Do you have the GHOA assignment pulled up?
All right. So, what are we doing right now?
The GHOA assignment. Do you have
Okay.
that pulled up?
Okay.
Yeah, so it says that we should start by just asking any questions we have, but I don't have any, but I probably will once we get going.
Yeah, same here.
Yeah, I think the questions will come up as we do this stuff, so I vote that we just get going
Okay.
on the extension problems. I guess, do you remember where our test was taken? Like where the content for this new section starts and stops? I mean, I guess it stops with what we've just done, but do you know what content's going to be on this test?
From what I can tell, I think if you go to resources,
Exam 1B instructions, maybe?
Yeah, they have exam 1B review. So we got section 7.1, law of sines, section 7.2, law of cosines, and then 7.3 vectors. So that's I
Okay.
think that's all that's going to be on there.
So law of sine, law of cosine, and vectors? That doesn't seem like much content, but
Yeah.
I mean, I'm not complaining if that's the case. Okay. Fair game. Okay, well, Yeah, let's just see if we can do extension problems and ask questions where we have them. So let's just start with the first part of 1. So solve the triangle with the given information. So we'll just have to use law of cosines or sine or whatever.
Wait, so can you see me?
No, I can't.
Okay. I don't know how to fix this.
No, it's probably fine. We'll just, as long as we can communicate, that's the important part.
Yeah.
Okay.
Okay, so for the first one, is that law of cosines?
Well, we've got 3 sides. So whichever one's side, side, side. I'm trying to remember. I think it would be law of cosines, but you'll have to mess with the formula a little bit.
Yeah. Yeah.
Well, I'm trying to make a formula to make this go easier, and I think it's just going to be harder than just plugging stuff in and then rearranging. So I might just plug and see what I get.
Okay. Okay, so I got alpha. I think it should be around 17.33.
Hmm. Okay, I was trying to figure out how to rearrange it the whole time, and I needed to just look in my notes because I had it there.
Do you want me to tell you?
I'm looking up the formula. I've got it here. I haven't done it yet. You can move on if you want to start the next one or whatever.
Okay.
The next part.
We got to.
I think we need to solve all the angles though.
Beta and gamma.
Man, these numbers I'm getting do not seem right.
What are you getting?
17.33 for alpha, 21.23 for beta. I haven't done gamma yet.
Well, so far you're correct.
Okay. I mean, it just seems like they're really small, but I guess C is way longer than the other ones, so
Yeah.
it's probably fine, I guess. And then gamma 141.43.
Yep.
All right. Well, I'm satisfied with that. Have you started the second one yet?
Yeah.
Okay, I'm going to start it. That's weird. I got an error.
You get well, it's not so weird.
Did you get an error?
No, not quite. I got gamma as 1.83 degrees.
Whoa.
So I thought that was kind of odd. So I double checked the answer key and it says that there's no triangle there.
No triangle. Okay. Oh. Is there like a systematic way we're supposed to know that? Because like looking at the angle 39.6 degrees and a side of 3.7, like you can tell that's not logical, but I just didn't question it.
Yeah.
Maybe I
I
should.
think it's because side C is just too big.
Right. Yeah, side C would have to be like, I don't even know, like the angle would have to be like 178 degrees.
Yeah, something like that.
Well, okay. No triangle then. We need to remember that that's an option.
Yeah.
All right, let's try 1C, or the third. Hang on. Error, what the? .6 sine.
This last one's kind of getting me.
Yeah, I got an error and I really don't know why.
I mean, I got an answer, but it's still kind of off of what they got. Also, it says this one has 2 triangles.
What? I don't understand why I'm not getting an answer here. Let me try it again.
Where are you plugging in?
I'm doing 38.6 sine of 115.64 degrees over sine of 32.7 degrees. Trying to find C.
Wait, over sine of 72.7?
32.7.
Oh.
Okay, I got an answer that time.
What'd you get?
64.41.
Okay.
Why am my answers are off?
Yeah. The thing is, it's only slightly too for me. I was finding alpha. The answer is 33.8, and I got like 31.75.
For alpha,
Yeah.
I got 31.66. I wonder why we're not getting the same answer.
I don't know.
That's really weird.
Because it should be arc sine of 37.5 sine 32.7 over 38.6.
Yeah, that's exactly what I did. That's weird. I don't understand why there's variation there.
Oh no. Do you think the key is off?
Well, I mean, why do we not get the same answer though, you know? Because I plugged in exactly what you said, and I'm looking at it right now on my calculator, like I put it in correctly.
I'm just wondering how we can't freaking get 33.8.
Yeah. I certainly didn't get that. Well, I'm going to assume the key's off. because I'm not gonna. I mean, that's the exact technique I've used on every single one of these questions, and it's been right every time. So I'm not doubting that. Yeah, I don't know. Let's just move on.
All right. I'm fine with that. Okay.
Number 2.
Given W and Z, the direction and magnitude of W. I forget. How do you find direction again?
Direction is theta equals inverse tangent of B over A.
That's right.
But you always have to make sure it's in the right quadrant too.
Oh.
Which mine is not.
What's yours?
Negative 33.69 degrees.
That's what I got.
Yeah, so if we look at W, it's negative 3, 2, right?
Yeah.
So if you think
So
about
that's quadrant 2?
yeah, and negative 33 ends up in quadrant 4, right? And so a rule of thumb we can use is if X, I say X or A, like the first number in the parentheses there, if the first number is negative, you add 180 degrees every time.
Okay.
So plus 180, so 146.31 degrees.
Nice.
So now we need magnitude. Which I got square root of 13.
Yep. That's what I got.
Okay. Now 3W plus 2Z.
Hey, so for part 3 of 2, I do you times the x and y's together first, and then add what's ever left?
So you'll basically, it's easier to just multiply both of the things in the W by 3, multiply both of the things in Z by 2.
No. In part 3.
Oh, okay. Sorry.
Nah, that's fine.
In that one, gotta remember, let me check here. Yeah, so multiply the first two plus the second two multiplied. So AC plus BD, if that makes sense.
Okay.
AA plus BB.
Okay.
Is that
Alright.
what you were saying? I didn't.
Nah, that's fine. I was just confirming something because I already times A and B together, but then I checked the answer key and I was like, well, that's not quite right. But then I thought, oh, maybe I can just add them together and that'll get me the right answer.
Yeah.
So I just want to make sure.
Is the answer for that one negative 17?
Yeah.
Sweet. And for the prior one, the 3W plus 2Z, did you get 1 and 4?
Yep.
Cool. Well, I think that is fairly straightforward. Yep. You ready for 3?
Yep.
Find the component form of the vector given the magnitude is 3.5 and the direction is 205 degrees.
How do you find component again?
So that gives us the polar coordinates, the 3.5, right? That's the magnitude. Direction is 205, and so we need to convert that back to component, which we would use x equals r cosine theta and y equals r sine theta. R being 3.5 and theta being 205 degrees.
Okay. Wait, so it's r equals cosine theta?
Yeah, x equals r. Let me check. X equals r cosine theta, and y equals r sine theta.
Okay.
You'll just do the two separate formulas for the two separate points. And I got negative 3.17 and negative 1.48.
That's what I got.
Okay. And let's just check. So the direction 205 degrees, that's third quadrant. And negative negative is third quadrant. Okay, it checks out.
Okay.
And that's what the key says too, which is perfect. So I'm guessing on number 4, it's wanting us to convert component to polar or vice versa, depending on whatever it's in currently.
Okay.
So the first one's component to polar, the second one's polar to component, third one is polar to component, fourth one is component to polar. Do you remember the formulas for that?
Nope.
Okay, that would be the r equals square root of x squared plus y squared, and theta equals inverse tangent y over x. So once again, that's just, I mean, that's magnitude and direction again.
Oh, okay.
They're the same formulas.
Okay, so that's what it's talking about. Whoa. Hey, what did you get for your theta? wait,
negative
hold on.
51.34 degrees.
Okay. And so in this case, we would add 360.
Yeah. I'm not sure why. I mean, you end up in the same place. It likes it in a certain form a lot of the time, and I don't remember what the forms are.
Yeah. Well, from what I'm starting to remember is if it's in quadrant run, you leave it be. If it's in quadrant 2, you add 180 to it, and then if it's in quadrant 4, you add 360 to it. And then I can't remember what you do with quadrant 3.
Well, I still think there are cases where you want to leave it negative if it's like tangent, because it needs to fit on that side of the unit circle that's between negative pi halves and pi halves.
Yeah.
And so I don't know. I'm gonna have to look over that. Yeah, I don't know when it's supposed to be plus 360, but I guess this is one of those times. Are you good on that first one then?
Yeah, I finished that one up, and I also finished up the second one.
Nice. I'm just starting the second. I think on the third one, doesn't it like it when your formula is equal to 0 at the end?
Uh,
Trying to remember where to stop on this one.
I can't remember. I skipped 3. I did 4.
Oh, okay.
Now I'm just about to go back to 3.
What the crap? The answer in the key is like weird. Pretty sure that's not the cleanest way to do it. Oh, I did make a mistake actually. There. I'm pretty sure the key is wrong for number 3.
Oh
I
yeah.
mean, the answer he gets there is just bogus. I have no idea where that came from.
So what did you get for 3?
Not that. I got x squared plus y squared equals 5x.
Okay. That's what I got. Sometimes I wish they like go through the problem on
I know,
these
because
answer
like,
keys.
yeah, I need to know if he made the mistake or if I made the mistake. Because I'm not convinced that I made the mistake there. I
Yeah.
have no idea how he got any number divided by 2 or divided by 4. That just doesn't make any sense to me.
Yeah.
Not sure how to do the fourth one though.
So the fourth one. So what you do is you change y and x to r sine theta and r cosine theta.
Right.
And then,
Did you get the right answer?
yeah, I did.
Okay. All right, yeah, continue then.
So then you distribute the -3 to r cosine theta. So now you got -3 r cosine theta. Then you add uh, +3 r cosine theta to each side. And then you
Hang on, you add what to each side?
+3 r cosine theta.
Okay, to bring it to the other side.
Yeah. So then afterwards you pull out an r from r sine theta and 3r cosine theta.
Let me let's see. Okay, hang on. I think I get what to do. Let me just check. Okay, yeah, I got it.
Okay,
Thank
cool.
you.
Yep.
I totally forgot you could subtract, or that you could add the 3r cosine theta over. I was like trying to figure out what do I do with that 5?
Yeah.
But no, that worked out just fine. Well, I think we're good on that. I don't know, that third part on question 1 and then the third part on question 4.
Yeah.
Not sure. if we would have made a mistake there or what happened, but whatever. I'm not that concerned about it.
Yeah.
I'm sitting at like a 98 in the class, so
Ah, dang, dude.
I'm not super concerned at the moment. Oh, that didn't work. All right, shall we move on to the group quiz?
Yeah, let's do it. Let's finish this out early.
Yes, please.
I always hate it when it says determine the number of triangles.
I know. I still don't quite understand where that comes from a lot of the time.
Yeah.
All right. Determine the number of triangles and solve the triangle with the given parts. Well, so far it seems like just one triangle to me.
Okay. I think I got all the parts for number 1.
Okay, I'm working on the last part.
Okay.
Give me just a second.
Unless there's things like 2 triangles, which I don't really know how to tell.
Yeah. Okay. So I got A equals 3.5, alpha equals 51.15 degrees, and beta equals 68.85 degrees.
That's basically what I got.
Okay. Good deal. Number 2. Oh, let's do the triangles, I guess. So we're given 60. We're given 60 degrees, we're given 4.2 and 3.9. So I think gotta think about this. I think there might be 2 triangles. But so I'm looking at it based on the information it gave us to start with. So there's that 60-degree angle,
Uh-huh.
and then the bottom side of the triangle is 4.2, and then the side that attaches to 4.2 but not across the angle is 3.9. So we have 60-degree angle. This side we don't know anything about, but this side's 4.2 and then 3.9. So that 3.9 is shorter than 4.2, which means that along that angle, it could hit up here or here since it's shorter than the bottom side.
Uh-huh.
I think. I'm going to open up that. It's the SSA PowerPoint. Yeah, okay, so I think there's 2 triangles because the length of C is longer than the height would be.
Yeah.
Does that make
I thought
sense?
something was up because I tried using Pythagorean theorem,
Yeah.
and I keep on getting like 5 point something. Like no matter which combination I use, I always get like a 5 point something or other.
Well, it's not a right triangle, so I don't.
Oh,
It
okay.
doesn't work if it's not a right triangle. I don't.
Oh,
I
okay.
don't
Never
think it
mind then.
does. Um, yeah, so if we look at that 60-degree angle in 4.2, like you would think that, man, drawing this out would be a lot easier, but I'm not sure how to do that.
Yeah.
But yeah, since 3.9 is pretty close to 4.2 and it's only a 60-degree angle that makes that, that makes me think that that 3.9 is longer than the height. Height being from angle gamma to alpha. It's man, I don't have the terminology to even explain my thoughts.
Yeah.
But I'm gonna say two triangles.
Okay. How do we solve for the second one then?
The second triangle?
Yeah.
Well, I don't. I was kind of hoping we wouldn't need to, but I don't know if we need to or not. I guess what we could do is find the height and just make sure that 3.9 is longer than the height. Do you remember the formula to find the height of a triangle?
I didn't even know that there was a formula for it.
I think it's, no, that's alpha. What's height? Or alpha, that's area. Well, let's check. If I do it like this, '60, 30, 60, 90. Okay, so the height is 3.63. And so 3.9 is larger than the height, but smaller than 4.2. So there is two triangles confirmed.
Dang it.
So in order to find the height, you draw, the perpendicular angle, and that's going to be 90 degrees.
Okay.
And so you just make another triangle in there, knowing that that's 90 degrees. You know that the one angle is 60, and so the other one must be 180 minus those two.
Okay.
Which comes out being 30. I mean, pretty simple, right?
Yeah, sure.
And then you just use law of sines to find the other side, which ends up being the height. And so the height is 3.64. So So, 3.9 is greater than 3.64, which means there are two triangles. Yay. Oh, well, this blows. The second triangle is going to be like a little sliver of a thing. Dude, I can't even draw a sliver on here. A little bit. You can do another. I'm honestly just coming up with crap on my own, trying to figure this out because.
I'm sorry.
So 51.15 degrees minus 30 degrees equals 1.15 degrees, which is the difference between so 8.85 degrees.
Yeah, I'll be right back.
Okay.
Okay. So, how's it going?
Well, I got an answer, and I'm hoping it's right.
Awesome. I agree
Basically,
with it
what I did
wholeheartedly.
is, what's that?
I agree with it wholeheartedly.
Thanks. I appreciate the support. Yeah, I'm just gonna run with it. I mean, it makes sense to me.
Yeah.
It's a lot of work, and it's work that's gonna be hard to explain because it's just using general trig knowledge of like, well, if this angle is this one, then this angle must be this, you know?
Yeah. It's
And
all good. I'll just review that PowerPoint.
yeah. All right, number 2. Determine the number of triangles and solve. Yay, another
This
one.
one also kind of confused me. I started to do it while you were doing that,
Okay.
but I I just don't get it. Like you have A, B, and gamma.
Well, A looks like it's going to be ginormous. It's not. B is bigger. That's still fair. 17 degrees. I'm pretty sure it's just one triangle.
Okay.
I think it can only be, I think there can only be multiple triangles if it's an angle side side situation. Because if you have an angle and you have the exact lengths, all you have to do is connect the two dots and that's it, right? Like
Okay.
there's no other variation that there could be.
Yeah.
So one triangle, I'm gonna say that right now.
My question is, how do you start this one?
Um, Law of cosines.
Oh, the law of cosines?
Yeah, side angle side. Um, if you don't, what I've realized, like the definition didn't really make sense to me with like the side angle side side, whatever. That didn't make sense to me, but I've noticed that when you do the law of sines, you need alpha and A
Yeah.
or beta and B or gamma and C. If you don't have both of those, then you can't do law of cosines. So
Gotcha.
that's what I look for every time. And then since there's nothing across from that angle, I just know that it's not law of sines.
Yeah, I kept on seeing it as a law of sines because of the side angle, but there's also the different variation where it's for law of cosines.
Yeah. Yeah, that works for me. I've got that in my head to the point now where I know if I don't have the angle and its corresponding side, then you can't do law of cosines. So it must be the other one. Okay.
So I got 1.47 for C.
As did I.
Okay.
Okay. Now we just need one of the angles, and then we can subtract to find the other.
Okay, I think I got beta and alpha.
Okay, I'm getting beta right now. Give me 1 second.
Okay.
Okay, what'd you get?
I got beta as 50.9 degrees and alpha as 112.1.
I did not get that. Hmm. I'm not sure how to tell. So you got 1.47 for C, correct?
Yeah.
And then did you do, let me think about this. C squared. And then you did the law of sines, right? To
Yeah.
get one of the angles. And which one did you get first?
And I did arc sine of 3.9 sine 17 over 1.47.
Okay. So 3.9 is not across from the angle 17 degrees, right? 3.9 is B.
Yeah. Should I have gone with A?
Hang on, let me think about that. You tell me what you did again.
So I did arc sine of 3.9 times sine of 17 over 1.47.
Okay, so when you set up your equation, this is what I did. I did sine of 17 degrees over 1.47, right?
Okay.
Equals sine of alpha over 2.8.
Okay.
And then you multiply the 2.8. I didn't use 3.9 at all. I tried to find alpha before beta.
Okay.
Um, I think we just called our alpha and betas different, but yeah, say we had done 3.9, which you could have. What answer did you get from that?
For alpha or beta?
For the one you were telling me just now.
Oh, it's about 50.9.
Um, 50.9. Oh, I'm so confused. I got that too when I do it that way. I'm just confused why we got such different answers. Okay, so what I did is I did inverse sine of 2.8 sine 17 degrees over 1.47.
Okay.
So I just used the other side, which should just give me the other angle, right?
Yeah.
So it seems like you got one
Let me
angle, I got
try
the
that
other
real
angle.
fast.
What's that?
Let me try that real fast. Yeah, that is weird. So for alpha, you got 33.84, something like that.
33.81 is what I got.
Okay.
Because I used the 1.471157, like I didn't round it.
Oh, okay, gotcha. All right. But yeah, I see what you're saying. That's weird.
That doesn't make any sense to me. Why are we getting, the only thing I can think of is maybe we're getting two different triangles and it's not just one triangle, but
Uh,
I don't see how that could be the case either.
yeah.
There's no way. Like, there's got to be something we're missing here. My only thought is there any chance that there's no triangle?
Yeah.
Um, I mean, how would we tell if there's not one? It would be to see if 1.47 is longer than. Dude, this is insane. I don't understand.
Yeah.
So, in theory, if we were to have another triangle, Not good. I don't know, man. I have hit a roadblock.
No worries, man.
I honestly, uh, I mean, the only way it wouldn't make a triangle is if that angle is too small. Is if 17 degrees puts the lines too close for no, even then it'll just
Yeah.
I don't get it. I don't know why we're getting two answers. Yeah, I have no idea. This one's over my head.
Yeah. Sorry, I'll be right back. I gotta use the bathroom.
Okay.
Sorry about that.
No problem. I think I got number 3.
Oh, yeah?
Yeah, what I did is let me just check something really fast to make sure that I didn't break any rules. I did not. Okay. Yeah, basically I just did the 3u minus 2v, got a new vector, which was -9, -1, and then used that vector to find the magnitude and direction. So I put that into the square root of a squared plus b squared, and got square root of 82. For the magnitude and the direction,
Okay.
I just put that into the inverse tangent of -1 over -9 to get 6.34. So I think that's fair.
Yeah. That sounds like it works.
Yeah. I don't see much room for error there, so I'm going to run with that. Let's do number 4. So we have a polar equation and we need a rectangular equation, which is the same as a component equation.
Isn't this one like similar to that last extension problem?
The one that we got wrong, yeah, it is.
Ah.
Or the one that we didn't understand.
Yeah, because I was going through it and I'm like, wait, this looks way too familiar.
Yeah, seriously. So like because I look at that and think, okay, if I times both sides by r, that's fair, right?
Yeah.
So I can get r squared equals -6 r cosine theta, and then use the r squared equation, like substitute r squared with x squared plus y squared, and then substitute r cosine theta for x, and then I'm done. Like, I don't see why I can't do that.
Yeah, I don't get it either.
I mean, I swear that's right, but I don't know. I'm doubting myself now. I wish I understood how he did it on the extension problems, because that still never made sense. I just don't know what else you would do, you know?
Yeah.
I don't know.
Yeah, I'm trying to look back in my notes, and there's like similar problems, but there's none that are exactly like it.
Right.
The only other thing that I can see that we can do is
Well,
just.
time out.
Oh, okay.
I just watched a video of him doing exactly what we did.
Oh, really?
Exactly what we did, except he set it to 0 at the end, which I don't know if that part's necessary or not. But I mean, he literally just did exactly what we did. I'll
Oh,
send you a picture. That I mean, that gives me more confidence in trusting this.
yeah.
I watched his video, and yeah, he does it here. So come on, phone, you can do it. All right, yeah. Let me know when you get that.
Okay. But yeah, the only other thing that I thought of doing is just taking out an X from each side and then adding 6 to both sides. So you got y squared plus x plus 6 equals 0. Okay, I got it.
Tell me your thoughts.
Uh,
Isn't that exactly what we're doing?
Let me see here. Yeah, that's pretty much it.
So, I mean, what else could we? I don't
So
know. I'm
probably
like baffled that.
just have it as x squared plus 6x plus y squared.
Yeah, that's what I did. I'm gonna leave it
Yeah.
like that, and if he says it's wrong, I'll challenge him on it. All right. That means we're done then.
Sick.
I mean, he taught me to do it that way, so if it's wrong, you know.
If it's wrong, it's the teacher's fault.
All right. Well, let's be done, huh?
Yeah. Well, you have a good night.
You too. I'll get this stuff sent in and we can move on with our lives.
All right, cool. You have a good night.
Yeah, you too. Good luck on the test too.
Yeah, you too.
Okay,
Bye.
see you, man.